Next set of questions from 5.2 where we have to convert the given complex numbers to their polar form. So the first number given to you here is 1 minus I. Okay, so for polar form we know this is a polar form, r cos theta plus I sin theta. That is how we write it in polar form. So we need to know r and theta. We'll have to find out from this. Okay, so r, which is modulus of complex number z, is given by real part square plus imaginary part square. So real part was 1, imaginary was -1, which is coming out to be √2. Okay, then if theta is the argument, then we know tan of theta comes out to be imaginary part upon real part. So imaginary part -1 upon real part, which is -1, and 1 we know corresponds to tan of pi by 4. So 1 is tan of pi by 4. Now next we need to check in which quadrant this particular complex number would fall. So for that, what are we going to observe? That the real part is positive and its imaginary part is negative. Okay, for the given complex number, its real part is positive, imaginary is negative. So real, positive, imaginary, negative. That happens in fourth quadrant, right? So in fourth quadrant, the angle is taken as minus of theta. So that is why we will take the argument of this as minus pi by 4. Okay, ये negative इसलिए आया because of being minus pi by 4, fourth quadrant. So then simply now we need to put the values. We had evaluated our r as √2 and theta came out to be minus pi by 4. So this would be its polar representation. See the next one, which is -1 plus I. So modulus of z, which is r, is real part square plus imaginary part square, which is again coming out to be √2. Tan of theta is real part upon imaginary part upon real part, which is again coming out to be -1, but the quadrant will be different because this time your real is negative. Okay, so real is negative and imaginary is positive. So we are going to second quadrant. So our argument will be falling in second quadrant, and in second quadrant we've got to take the angle as pi minus theta. Okay, so ये pi by 4 को correspond करेगा obviously, but the angle will be not taken as pi by 4, it will be taken as pi minus pi by 4 to go to second quadrant. So pi minus pi by 4, which comes out to be 3 pi by 4. So आपका theta हो गया 3 pi by 4, and r was once again √2. So the polar representation, polar form of this complex number would be √2 bracket cos 3 pi by 4 plus I sin 3 pi by 4. Okay, ये तो standard आपको result remember, you have to remember that, and then you need to just put the value of r and theta once evaluated from here. For the fifth one also likewise, if you see in all these it's 1 1, it's just the matter of argument will change. Modulus आपका same रहेगा because 1 है, चाहे +1 हो -1 हो. So straight away we've done it already twice. We know that r will come out to be √2. 1 1 or -1 comes to the same. But this time the argument will change if both are negative. Real also negative, imaginary also negative. So you need to go to third quadrant. And for third quadrant, the argument is given as minus of pi minus theta. Okay, so that we had discussed earlier. So your amplitude will come out to be minus of 3 pi by 4. Put the values and your polar form comes out to be √2 cos minus 3 pi by 4 plus I sin minus 3 pi by 4. Okay, now the next one, sixth one, is given to you as -3. That means this is a purely real complex number which has only real part. So just putting it in standard form to make things clear, I have written it as -3 in complex form can be written as -3 plus imaginary part is 0, I0. Okay, so for finding r will come out to be 3. Okay, जिसमें खाली purely real purely imaginary होता है तो मॉडुलस उतना ही नंबर आ जाता है. If you do it, I have done it proper way also, then also it is coming out to be 3. Then tan theta would be again imaginary part upon real part, which is coming out to be 0. So when is tan theta 0 now? It's either at 0 or maybe at pi. So for that you'll have to check again the components. So हमारा जो real portion है, real part वो negative दिख रहा है यहाँ पे clearly. So real अगर negative है means ये वाली coinciding line है. If that's your origin, here it goes as positive, this way negative. So your argument will be taken as pi, not 0. अगर positive होता तो आप 0 लेते. Okay, negative value है तो pi आएगा. So argument is pi. Hence, in polar form, this number will be written as 3 cos pi plus I sin pi. Now, another thing children out here is we can quickly cross check also. See, अगर आप इनकी values रख दो and then you simplify it, you come back to this form. See, like cos pi. What is value of cos of pi? Cos of pi is -1. Okay, and sin pi is 0. तो imaginary part इसका 0 हो गया and यहाँ से 3 into -1 will give you -3. तो जब भी आप polar form में cos theta sin theta रखते हो and simplify करते हो, you once again get back your z a plus ib form. So you can easily cross check also from there. Okay, all right. Now for the 7th one, real part is √3, imaginary part is 1. So your r or modulus of z is coming out to be 2. √3 square 3 plus 1 4 under root of 4 2. And tan theta would come out to be 1 upon √3. 1 upon √3 we know corresponds to pi by 6. Tan 30 is 1 by √3. And दोनों positive थे, means ये first quadrant में है, तो ये angle as it is ले लिया जाएगा. Hence the polar form would come out to be z is equal to 2 r cos theta came out to be pi by 6. That's your polar form. Alright, then the last one here was simply given as I. You had to write I in polar form. So standard में अगर लिखना चाहोगे तो real part 0 plus 1 times I. Imaginary part 1 हो गया, real part 0 हो गया. So I is equivalent in complex form as 0 plus I into 1. So your R is coming out to be 1 only, and tan theta would be imaginary part upon real part, so not defined. That means your theta would be either pi by 2 or 3 pi by 2. अब पॉजिटिव है तो pi by 2, नेगेटिव होता तो 3 pi by 2, right? Positive would go as pi by 2 and negative imaginary would be 3 pi by 2. बट यहाँ पे पॉजिटिव था, so we'll take it straight away as pi by 2. अगर माइनस आई होता तो आप इसे 3 pi by 2 ले लेते. Okay, so you would say in polar form this I will be written as, ये तो 1 था, so it doesn't make any sense writing 1 bracket, so we are simply writing it as cos pi by 2 plus I sin pi by 2.